Behind this ordinary action, which we accept with the nonchalance of a modern-day Aladdin, there is an army of skilled workers and technicians, the men and women who supply us with electricity. There are vast electrical power plants, such as the one we're viewing now, located in Pittsburgh, California, and owned and operated by the Pacific Gas and Electric Company. It is from the installation sources such as this that electrical power originates. Massive generators touching the daily lives of all of us. Produces electricities in quantities to stagger the imagination of such men as Benjamin Franklin and Thomas Edison. If they could see today how very far their early pioneer efforts have been extended. One of the highest-ranking names associated with the history of electricity is that of George Westinghouse, the prolific inventor who pioneered the alternating current type of electricity used throughout the United States today. He reasoned a device could be developed to raise or lower voltage, to step up the voltage from a generator in order to send it over great distances by lines supported by the familiar towers, and to step down that same voltage at its destination, the homes, the factories, stores, and offices of the American people who use it. His original rough sketch for this device is the same design basic to transformers today, as we see it represented here. And it becomes our introduction to the success story subject for tonight, the Westinghouse Electric Corporation Sunnyvale Manufacturing Division.
Possibly the most important single piece of electrical equipment in the process of getting electricity from the source where it's generated to your home where it's used is the transformer. Tonight we're going to see if we can find some of the reasons why as we watch transformers such as this and other types of transformers manufactured here at the Westinghouse plant in Sunnyvale. With me is Mr. Leonard Goodell, the manager of electrical products. Mr. Goodell, I'm going to pose that basic question to you first. Just what is a transformer? What does it do?
Well, a transformer primarily is a means of transforming voltages up and down, as the name designates. Primarily and basically, there are two kinds of transformers, power transformer and distribution transformer, Bob. The power transformer is the one that's used in the big power stations, and it transmits voltages to a very high voltage over the transmission lines to the steel towers we're all familiar with in our backyards. We then transform that voltage down to a lower voltage into these distribution transformers and in turn into your homes.
Well, these kind, at least from the outside, are familiar to all of us. I think it's the type we always see up on the pole. I'm curious, though, just what part did they play in my life or the life of any individual?
Well, Bob, let's answer that as we go along, and I think we can give you that answer.
All right, we'll take that on faith for the time being, Mr. Goodell. Right now, though, however, we'd like a little bit of an explanation of the very involved insides of this particular transformer here.
Well, Bob, this here transformer is a cutaway sample. Normally, this transformer is filled with oil in this inside. Here we have all the coils we're going to see being made tonight, the core, as we call it, or the magnetic circuit, all the leads up through to these bushings, which are the high voltage leads connecting to the outside lines, our lightning arrestor, which protects the transformer, and the wires coming out to the low voltage, which goes into your home.
Well, now that you've given us at least an idea of what it is we're going to see manufactured, let's get to the first step in the making of one of these distribution transformers. What do you do first?
Well, in distribution transformer, Bob, the first thing we should be doing is making a low voltage coil. And here we see one of our operators winding a low voltage coil with a fairly heavy conductor for its size.
Well, that's a covered wire, an insulated wire, is it?
Yes, this wire, Bob, is covered with a special paper for that particular rating of transformer.
How does he know how many turns to put on, or isn't that important?
Oh, that is very important, Bob. The design engineers determine the number of turns. It is determined by a mechanical counter on the machine, and if even a half a turn was left off, you wouldn't get the right voltages in your home.
This appears to be a very slow and painstaking job here.
Yes, it is, Bob. It's very precise. It has to be compact and tight, and the layers laid on there very evenly.
I notice that occasionally he ties them together, too.
Well, that's very important, Bob, so that when it comes off of the mandrels, these coils will be compact and solid. And as you see them here, they're putting an outer protective covering on it so that when it comes off, it'll be protected during its operations.
A little bit curious about the machines, Mr. Goodell. They're not like anything else we've ever seen. Are they made to your own specifications for this purpose?
Yes, we have to make machines for this purpose because it isn't like a lathe, Bob, which you can buy in a regular machinery company. You have to make these for this purpose.
And this is the coil from which the current will come that we use in our house?
That is right.
Let's see now, in view of the fact that this is a long, involved process, let's see what a finished coil, a finished low-voltage coil looks like.
Well, Bob, here's a finished low-voltage coil. This is what we call the inner low-voltage coil. Here's what we call the outer low voltage coil, and later on we'll see what happens to the high voltage coils.
Now, you mentioned two different kinds of transformers. Are they all basically the same? Do they all have the same parts?
Basically, either power or distribution transformers, Bob, have the same parts. The only thing difference is size, and the larger they are, the bigger the capacity of the transformer.
Now, you mentioned the high voltage coil, the one in the middle, in the middle of the sandwich there. How are those made? By a similar process?
Yes, Bob, they're made in a similar way on a different kind of machine, which is much faster, of course, because they're winding with much smaller wires, as you see here.
Is the smaller wire a characteristic of the high voltage coil?
In general, that's true, Bob. In this case here, this is quite a small distribution transformer because that wire that this girl is using is only about 25 thousandths in diameter. And as you see, she's putting on there nicely in layers.
Yes, and I was going to mention that that must take a good deal of skill.
It does, because it's a hand-feed operation, and we can't have any crossovers or spaces between those wires.
It takes a while before you can do this right, then.
Yes, it takes a long time. We have to train our own people, Bob. And we have a lot of people here, these girls in particular. They've been here for over 25 years.
I notice that every once in a while they slip a layer of paper in under the wire. What's the purpose of that?
Well, the purpose of that paper, Bob, is to protect each layer from each other, and at the same time it acts as a guide so they can put the wire on there in layers evenly, which is very important in this construction.
Also, there's some little squares and various shapes of apparently corrugated or fiberboard that goes in there. What do those do?
Well, Bob, there's two kinds. One is a spacer and one looks like a corrugated spacer, but they both act the same way. They're actually in the middle of those coils, and they perform a space so that the oil can circulate through there to dissipate the heat in the operation of the transformer.
Looks like there might be miles of wire on this one coil.
Oh, yes, Bob. Probably there's more than a mile or 2 miles of wire in that transformer right there.
All right, now we've learned a little bit about the high voltage coil. Let's look again and see exactly what the part it plays in the completed coil itself.
Well, Bob, we said that we saw the low voltage coil being wound and the outer low voltage coil, and we just now saw the girls winding these high voltage coils. Here are some of the spaces we use to provide the duct formers and spaces for oil, and they all telescope right together as in a complete assembly, and it will finally look like this after we put together these parts.
Now, you mentioned that both kinds of transformers have similar parts. Let's move over to the eastern side of the building to show similar coils for the big power transformers. Is this a coil?
Yes, Bob, that's a high voltage coil on a small power transformer.
Yet the wire that this is being wound with looks as big as the wire that was on the low voltage coil in the distribution transformer.
Yes, Bob, that is very true, and in some cases that's even larger than the low voltage wire in the distribution transformer, and that's because of the large capacity that a power transformer has.
Those are spacers he's putting in between there?
Yes, Bob, those are the same as the corrugated spacer in a distribution transformer, primarily to let the oil flow between the coils to keep it cool during its operations.
The part that it's being wound on, is that an integral part of the coil itself?
Yes, Bob, that's a special micarta tube, and that remains there, and that holds the coil in shape and also to act as an insulator between the other coils.
And this is an even more painstaking operation than the previous low-voltage coil we saw being wound.
Yes, Bob, while that looks like it's just a symmetrical winding, it's a very complicated winding, and it takes a lot of skill to put them together.
And we found still another facet in the matter of winding coils here at the Westinghouse plant in Sunnyvale, and this is neither slow nor ponderous. This happens very rapidly, as a matter of fact.
Well, that's right, Bob. This is just another way we're winding high-voltage distribution transformer coils. Here we're winding actually 6 at a time. You see them there. They got 6 wires feeding onto it, and actually they're one way to wind them all at once.
Each one of those shiny bands on that is a separate coil then?
Each one of those is a shiny band, just like as if one girl was holding each wire, only 6 going on at a time.
I suppose they have to count the turns here very carefully, too.
Well, they have to count them, but the machine does the counting for you.
Oh, I see. Now, can this be done with the low-voltage coils, too?
Yes, it could be, Bob, but it's not quite practical at this time.
And here's a completed piece as it comes off the machine, I suppose, there on the left on the table?
Yes, Bob, that's the complete assembly after it's been removed from the mandrel. And after they remove the mandrel, of course, they're taken apart in sections, and as you see them laying there, they're all individual coils, just as if they were wound one at a time.
We're rapidly approaching the area, ladies and gentlemen, where all of these components will be put together in the first sub-assembly. So let's check back once again and find out what parts we have to make up this sub-assembly.
Well, Bob, we've talked about this low-voltage coil and this outer low-voltage coil. We saw the girls winding the high-voltage coils. Now we've seen all this insulation here that we use for barriers, and later on that'll be put together in this coil to make a final assembly ready for the next step.
Where are these assembled?
Well, these are assembled in the next operation, Bob, on a bench here, And here we'll see the operators lowering the outer high voltage coils onto this high voltage coil, and they bend the leads out of the way, Bob, and next they will insert the inner low voltage coil, which will make the final assembly.
But those are just loose in there. What holds them in place?
Well, those 3 coils are loose now, but as I showed you these pieces of insulation, you see that man picking up one of those spacers. He is now getting ready to insert it between these coils so that the coils are equally spaced, and it also at the same time allows oil to flow between the coils to help radiate the heat while it's in service.
There are still quite a few leads coming off of this coil. Will some of those be connected within the body of the coil itself?
Yes, Bob. That man there is now brazing one of the connections between the inner low voltage coil and the outer low voltage coil. That forms the interconnections, and on the other side, of course, the leads will then go out to the bushings for the actual service operation.
Now, so far we have the coil manufactured. What will happen to it next?
Well, the next operation, Bob, is to take this coil and put it together with its iron, what we call the core of the magnetic circuit. And here on the bench you'll see the core blocks. With the insulation put in, the man is now lowering on a completed coil assembly. Here he's putting on a top yoke of the core block, and the second one, which forms all of the iron circuit that's required.
Goes together like a puzzle.
Yes, it goes together like a puzzle, Bob, but it's a little bit more complicated. We have a man here now that's going to take and put a steel strap through those coils and band this thing so it'll be complete solid assembly.
I'm curious about the core itself. Is that just a solid block of metal?
No, Bob. That is not a complete block of metal for the primary reason that it's very special. It's actually made of 14,000 thick electrical steel, and it's insulated between each of the layers. It goes through a process whereby the complete thing is made a solid block as you see it in this form.
And now we see the banding operation, which reminds me of the banding on wooden crates.
Well, that's not quite true, Bob. It looks like that, but actually these bands are special material, and they're banded with a torque tool. This torque tool puts a very precise tension on for each size transformer, and it cannot be very much more or very much less, because it's very important for the stability of its operation while it's in service.
There seem to be several banding operations, actually.
Yes, one of the banding operations, of course, is on the core block, and the next banding operation, of course, is to put the top and bottom frames together, which we'll see at a little later time here.
Now we've got the 3 coils and I guess there are 4 pieces of core block altogether by the time it's put together.
And this particular size, Bob, that's right.
Now, are there any other components that are added at this time?
Well, after the core blocks are put together with the frames, Bob, we put tap changers on next, and here we see a man putting on a tap changer. This is on the high voltage side of the coil.
And what's a tap changer? What does it do?
Well, a tap changer, Bob, is one means that utilities like to have to be able to vary the line voltage for certain local conditions so the voltage will be proper for each household.
Well, it's sort of a variable switch then.
Yes, very much so, just like a rheostat.
Now, all of these things that we've seen that go into the making of a distribution transformer, are there similar activities, comparable activities in the building of one of your power transformers?
Yes, except that they're very much out of proportion when you see them as the man is doing here. We just saw that little tap changer for that small distribution transformer. Here's a man connecting the leads to a large power transformer, and you can see that the size of the wires, the mass of the thing is entirely greater, yet this is really a small power transformer. Proportionally, it's much larger, though.
And once again, I suppose highly skilled work is necessary for these operations.
Yes, it's very highly skilled work is required here, and except that it's the same design, but the mechanics are entirely different.
Well, now let's get back to transformers that are more my size, the size I'm more familiar with, the distribution transformers we've been talking about. What happens to them at this point? They seem to be hanging on a conveyor line.
Well, those transformers hanging on that conveyor line, Bob, are getting ready to go into a varnish tank.
A varnish? You mean like household varnish?
No, Bob, this is is a very special insulating varnish. And this varnish, of course, is put on these transformers because as you saw, the transformer coils and blocks are all made up of pieces and put together.